This is our fifth installment in the Chatbot series, and in this one, we are actually going to learn about making things like simple games using chatbots like ChatGPT and Google Gemini. We're going to go over things like, is it actually useful, who it's useful to, when you should and when you shouldn't actually use chatbots for programming, and we're going to do a few examples using both Google Colab and P5JS to make some examples. We'll see how far we can get with this game in just a little bit of time and discuss a little bit of background about how computers actually work. Welcome to part 5 of our Chatbots series. Now, before we can actually start using chatbots to create things like this, we're going to go over a couple of principles like we always do, and today we're going to talk about coding. Now, I myself have programmed many games over the years, and I know a lot about programming, and it's really difficult and it takes years and years to learn. But perhaps we can skip the line and learn something that just lets us do what we want to do. I don't want to learn about programming. I just want to learn about making games. Well, we'll see how far we can go with that. And as a background, let's just start going over an outline of what we're going over in this class, this particular video. So we already have a pretty good handle on what chatbots are, but we haven't in this class actually talked about code at all. What is code? Well, it's a kind of a language that computers understand, and the first person to come up with a good model for it was von Neumann. So all modern computers use this von Neumann architecture, and it looks like this. We have a input device, something like a keyboard, something that you use. We have a central processing unit that has a control unit, an algorithmic logic unit, and a memory unit. And then we also have an output device, something like a screen, or in their days, maybe tape or switches, or just little blinky lights. The first computers were actually sort of mechanical. I don't remember if von Neumann was before or after that mechanical thing. But let's mostly talk about modern computers, and I'm not going to go over every single detail. I'm mostly going to go over it through a programmer's perspective. And to that end, we're going to talk about a couple of programming languages that we actually won't be using in this class. The first one we're going to talk about is a low-level class of programming languages called assembly language. And in assembly language, it looks kind of like this. You can write this in many different ways. This is a memory address. These are like instructions and arguments. And basically, all of the numbers that are here on the left, they correspond to things like the actual code for the operation that you want the computer to do. And then something about like the arguments that are actually in that function. And I'm using all of these words that you don't understand. And that's okay. But basically, there is a one-to-one correspondence between each line in this assembly and the actual ones and zeros that go into a computer. This is what makes it a low-level language. It means you have full access to everything inside of that chip, but it also means it is really, really, really difficult to program. For the makers of Atari, like that Galaga game that we looked at, that's all they had, and it was okay. And every once in a while, you have to just barely dip into that low level of languages. But typically, we use a higher language. And that higher language, one of them is called C++. Now, C++ includes a much higher programming language. And this higher level of programming language, let's see here. This higher level of programming language is based off of another programming language called C, And these are both high-level programming languages. They are high-level programming languages, but they're not like the highest level, meaning you have much, much less fine control over the actual bits that get created, but it's much, 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 much easier to code in. This is a typical kind of language you might use, C or C++, in an introductory college-level course for programming. And I want to show you an example of what compiling looks like. And so this site really, and I'll include it in the comments, gives a really good example of the most basic program using C++ and running it on an operating system like Windows or Macintosh or iOS or whatever. And this is called Hello World. It's the first program typically you write in any kind of programming language. And you don't have to worry about the actual things that are here, but this is high level. Instead of having to write every single digit for every single level letter, you can use this stdcout, std standard cout hello world. And what happens there, after that it gets compiled. You run a program called G++ to output a file called say hello. And when you run say hello like this, it says hello world. Wow, amazing. And it has to go through all of these different steps together. It goes from source code, it includes some extra code, there's a preprocessor step, and in that preprocessor step, it's finding these different functions, including this function to actually output information. Then the compiler generates this binary machine code. So this looks more like this assembly code that we were looking at just a second ago. And it finally creates what's called a binary executable. And it's called an executable because you can run it. And we're actually going to be using even a higher level. But I first want to just go over some of the principles of the differences between bots and the output they give you versus computer programs and the output that they give you. And so the things about chatbots, we kind of already know about some of their output and about the internals of how it works, right? The first thing is that it's probabilistic. That means it uses statistics and things, and it only sometimes gives you the same results depending on what your input is. The other thing that's a little bit unique to chatbots, you don't actually have to learn a new language. They're easy to talk to in the sense that you can just use your normal kind of speaking to do it. So it's very, like, we'll call it loose, or loose. We'll call it flexible. Flexible is a good word. Now, this is in stark contrast to code, where basically everything here is the opposite. Let's save that for last time. Let's have a general rule here. Okay, there's a couple more I thought about. Code has perfect memory. It can use databases, very explicit, very exacting understanding, and basically if you've coded it correctly, it should never forget anything, if that's what you intend. Whereas chatbots, they have imperfect memory. You may have just said something and it seems like the chatbot forgot it, and you're like, but I just said it. Also, when a chatbot is not aware of something, or it's missing some memory, it actually doesn't have a good way to be aware of that. It will just keep going. It'll say, heck yes, I can make you this. I can make you a calendar with 38 days if you want to. Whereas if you have an error like that in a computer program, a lot of times it halts on that error. It stops. It says, hey, there's a syntax error, there's a logic error, or there will be some built-in validation created by the programmer to make sure that the world indeed makes sense at that point. So before we make our game, I want to start with something called a Python notebook. And basically, Python is another one of these high-level languages. It's an even higher level language, which I will not explain, but you could look that up. And we're going to have it do something that chatbots can't do very well, which is, say, counting to 500. And we'll see if we can get a chatbot to do that real quick. And then we'll use it to write some code for us and then to upload that. So typically what happens when a programmer actually wants to do a little bit of code, they'll ask it some kind of a question, they'll have some kind of a query, and then the chatbot will have some kind of an output, and then they'll take that output and they will put it into a some kind of a programming environment. So that's exactly what we're going to do. Let's start it. So let's see what happens when I ask it to count to 500. If I click this button right here, maybe it will count to 500, maybe it won't. There it goes. It's going to count to 500 here. And it probably, oh my goodness, it gives up. It gives up based on excluding 3 of these numbers. And why would they do that? It doesn't want to do it. It'd be too long. It's too hard for this poor bot to do this. So we're going to ask it to make a cell block in Python instead. Instead, please make some code that I can run in Google Colab that prints all 500 numbers. So let's see what it creates here. Much more efficient. Oh, aren't we smart? And so what it's giving us instead here is this code. And it included some optional print a new line every 20 numbers for readability. I won't explain how that works, but you can just click. Okay, so from Google Colab, we can create a new notebook, and you don't have to worry too much about what the interface looks like and all of that. And basically what happens is we can scroll back up to where we got our 500. We can get this piece of code. We can copy that code to the clipboard. It has now been copied. And then if we hop back into our notebook, we can just hit Control V to paste that in there. Now, if I run this, it's going to have to like instantiate and do a couple things for the first run. But once it does that, it should be very fast. There it goes. So I think this optional make a new line every 20 lines makes a lot of sense. It printed out all 500. And you know what? We can even change this. We could change this to 5,000. If we change it to 5,000 and we run it again, wow. Look how fast that was. That was much, much faster than using a large language model. This is not super complex though. And what's interesting about these code blocks is you can do things like mathematical expressions to get that information back. And so Python is really useful for things like creating charts. So if you ask it to do something like actually create a chart, for example, give me some code to plot any quadratic formula with an example. Well, then it gives us this code. We can copy this code. We can go back to our untitled. We can paste it in there. And if we hit play, it's going to import a couple of things you don't understand, and that's okay. Matplotlib, this is for plotting things, visualizations, graphics libraries, and then NumPy, this is for manipulating numbers in an efficient way. And this is called a function. And because it's a function, it's got an A, a B, a C. And then down here, when we actually call it, this is like an example of using that function. And so we have A equals 1, B equals -4, and C equals 4. This is what the plot looks like, and it does a good job. Now we could change something here. We could change the A to a 3. And if we do that, we'll get probably bigger numbers at the beginning and the end. There we go, 350 all the way to 250 over there. And if we wanted this line to cross underneath, we could change the offset. So we could change C to like -40. And if we do that, the plot makes sense. There we go. And so it's really useful if the function is not too difficult. If the thing that you're trying to accomplish is not super hard, then it's easier for you to understand what's actually going on. Okay, so let's switch to another example then. We just used Google Colab for Python and we did some math with it. Now we're going to use something called P5.js, and we're going to try to make a small game. Before we make a game, we're going to start small. We're just going to do some kind of a visual. Now, what is P5.js? Let's take a look. So P5.js, this is a kind of something you can make with games, and let's take a look at what that actually is using the p5js.org website. So this is P5.js, and this is basically just a tool for learning about coding. You can make visuals. It uses a language called JavaScript, which is what a lot of the web works on. I might have mentioned this in our web part of this this series on media literacy. So if we keep scrolling down here, we'll see that there's a whole bunch of different information. There's a reference library, which talks about all of the different things in the code you can look at, but there's a lot of examples that are fun too. Here's one, and if we click on this, we can see what somebody else made. Oh, interesting. So it's like they have all of these geometric shapes, they're moving around, and if you wanted to, you could look at this code. And it has a setup function right here. And it does all of these different things. It uses a bunch of math to select things and to make that kind of happen. But instead of having to do that, we're going to just try to do what they call vibe coding. We're going to try to do it ourselves. So if you go back and you hit start coding, you get this coding interface. On the left here, we have the code, and on the right here, we have what gets created. So if you hit play, it will actually show you this code. And it's a little bit tricky, like I said, right? You could start and you could just make like an ugly line here, and if you try to run that, it doesn't work. Why? Because it's not probabilistic. And so if you have that kind of problem, you could copy and paste this and try to debug that with the chatbot. But I will start nice and clean like this, and as I run that, we have this system right here showing this canvas. We basically have a 400 by 400 pixel square that we can fill with something. And I would like to fill it with a blooming flower. So I'm going to copy this code right here by hitting Control A, hitting Control C, and then going back to our chatbot to do some things. So in this case, I'm going to try to switch to P5.js to make a blooming flower that moves slowly and has many colors. Here's the code I want you to edit. And now I'm going to paste that code in that we have in our clipboard. And hopefully it presents it to us in a little code block. Okay, it says a bunch of things like, oh, wow, that's so amazing, blah, 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 blah. And after it writes this code, let's take a look at this code here. It's editing canvas to change it to a particular color mode. It is creating a background that's a little bit darker, quote unquote, to make the colors pop. And then it makes these patterns, and you know, we can just copy it. We can go right back to our P5.js editor. And I'm going to hit Control A and Control V to paste it. And then if we hit run, hey, it works. Look at that. This flower kind of looks like the NBC logo. It's very rhythmic. Now, at this point, we can ask it to do things. And I'm going to ask it to change about twice as fast, that we can actually see that it's doing something. And this is one of the great things that you can do with little code snippets here. Okay. I'm going to say, okay. Make it move twice as fast. And then it's going to maybe do that here. So it's changing a particular thing, and it's printing out all of the code again. I hope it's printing out all of the code. It is. Okay. So I'm going to copy this code. I'm going to go back here. I'm going to paste it in. I'm going to rerun it. Look at that. It's moving twice as fast. It's pretty good. It's pretty good. We didn't work that hard. Now, if you wanted to do something more complex, it might be a little bit trickier. But maybe that's what the assignment should be, is to try to recreate one of those games and to see how it goes for you. Before we do that, I'm going to just ask it outright. And what is the game that we started with here? We started with Envoy Newman, Galaxin. Okay. Now, I'm going to ask it to do something that's kind of a little bit of a cheat, because this game already exists. There's probably code out there that the chatbot has read and integrated into its, limited memory to understand it. But let's give it a shot anyway. We'll just say thanks. Now, make a simple clone of this. And so we'll see if it can actually do that. Oh man, this is a big jump. Oh, you're making me work so hard here, is what the chatbot is telling us. And it's got to think for a little while, and it might not work. We're going to copy this. We are going to paste it in here. And we're going to see what happens. Hey, there it is. Now, I don't know how I'm supposed to actually move here, so I'm looking at the code to see. Okay, left arrow and right arrow. So if I go left and right, and I hit spacebar, there we go. We're pro gamers now. We can actually make this system, and the more you ask it to do, the more likely it will break. And I'm going to leave that for you as an exercise. And actually, there's a nice way you can actually publish this game. And if you can figure out how to do that and bring the link with you, that would be fantastic. Tick. Okay, so let's summarize. And I'm going to provide a couple of warnings as well for this whole idea of using large language models to do coding. So I want to just reiterate a couple of things I've kind of said already, right? One of the things is that programming is hard. Another thing you need to be aware of is that, you can take years and years and decades even to become a good programmer, and the kinds of things you need to know, they change all the time because the technology changes. The next thing you should know is that large language models lie. The chatbot might say, oh yeah, I can do that, and then it just can't do it. And I'll save this for you to try on your own at home here. So it's kind of like having somebody who can say, yeah, I can totally do that, and then they don't do that, or what they did is totally different than what you asked them to do. And this is an interesting contrast, right, between computers. Like computers, they always do exactly what you tell them to do. This is actually what makes programming kind of difficult. Now, something I don't have time to get into in programming, that really the first draft is the easiest draft. Why? Why is the first draft the most easy? Well, it's because it's usually the smallest and it doesn't actually have all of the things you might want. For example, in our Galaga game, something that's really interesting about programming is that, the Galaga that we made is maybe like 100 lines. A typical computer program, it could be like like 30,000 lines. And in that case, it's almost better to have less code. And so basically, it's really easy at a small scale, and it makes sense for large language models, and it comes to be very difficult. What they are very good for is like starting, testing. If you have some kind of an idea, you can make a rapid prototype. But if you're actually going to bring real code into a production environment, you're probably going to have to do it yourself. This is just the truth. And something that happens when you actually have code that works already, sometimes you think about it as technical debt. It's like, well, we've always done it this way, and changing it would actually be very expensive to do. This is what happens in companies. This is what happens like if you're trying to write a large book, like a novel, and you go, I don't know what's happening here. I need to do this, I need to do that. You could also use it for just about every language, right? Many languages, even C++ and stuff like that, but you get out of it what you put into it. Okay, so let's talk about homework for next week, and you can re-review this video if you need to understand what to do. So this next week coming up, I want you to try to make something in P5.js. Try to follow this example of copying and pasting that kind of starter code and then having the computer make something. It could be a simple version of lots of different things. If you run into an error, you might have to start over, or you can try to copy and paste that error into the large language model to try to figure out what's going on. After that, I want you to make it more complex. Make it so complex that it actually breaks, and then we can share and discuss this in class. If you're one of the younger students, it's okay if you don't actually do this. We'll talk about it in class. So that's it. I hope everyone has a great time. I look forward to talking with you in class, and think about how you can integrate these kind of ideas to prototypes and things maybe you didn't think you could do before. All right, bye.